Welcome to the DevFest. My name is Keith Shea. I am the Vice President and General Manager of the Helix Cloud IoT Solutions Business Unit at Wind River. It's my great pleasure to be here with you today, talking about how do we unlock business IoT. Let me start by telling you a little bit about Wind River and how we fit within Intel. Wind River is a wholly owned subsidiary. We're a part of the Internet of Things group within Intel. And across the Internet of Things group, we focus on several key verticals, primarily focused on critical infrastructure. Intel, as you know, is a hardware company focused on providing the world's best semiconductors. And Wind River complements that hardware capability with our software capability. We have a 30-year pedigree in helping people build secure, safe, and reliable systems. And now, as we're starting to transform our marketplace into a connected embedded systems world, Intel's providing the software that helps us do connected IoT. Again, safely, securely, and reliably. And when it matters, we like to say it runs on Wind River. So I'd like to start by sharing with you a video that we've produced that helps to give you some sense of how the IoT industry is starting to transform. So please join me in watching this video. Thank you. All right. I am not yet an expert in this platform, so thank you for bearing with me through that slide transition. So, as the title slide says, I'm here to speak with you about unlocking business potential with IoT. Today, what I'd like to do is frame the opportunity for you from my perspective. And I think the opportunity really is a data-driven opportunity. The internet is 20, 25 years old at this point, and if you look at the aggregate amount of data created in the first 2 decades of the internet, we're starting to generate that much data on an annual basis, given the massive number of connected endpoints we now have with the internet. The term Internet of Things, I think, it's a descriptor that we needed to distinguish ourselves from the traditional internet. But in reality, I think the Internet of Things is a term that probably won't persist. I think we're just going to talk about connected, embedded internet, or just the internet. But today, I think it is descriptive because it moves us beyond connected endpoints that we've become familiar with, like our laptops and our phones. And now we're really looking and we're striving to connect everything. I've shown you here on this slide some data points. But without going into those, I think the underlying thing that I want to emphasize is that with the amount of data that's been driven and our opportunity to generate insights from that data, and then furthermore with our opportunity to remotely manage the devices that are now connected to the internet, our opportunity is huge. If we were to quantify it at 100 billion or 200 billion, I think that becomes a little bit misleading because it's going to be that big, it might be bigger. The point is that it is big, and there's an opportunity for all of us to go and not just see a great financial return, but really we can change the way that people work and the way that they live. And that's what I think is really exciting about this opportunity. And as we go and we connect these endpoints, what we're really doing is we're starting to focus on the data that's locked up in these devices. And it's our job with IoT to go and unlock this data, connect these devices, create the opportunity for new insights from this data, and then create new opportunities to remotely manage the devices that historically have been locked down in an operational technology or OT environment. So how do we focus on our opportunity? Well, let me talk to you about some things that have been stalling us or present risks. Because whenever there's a reward, there are going to be some risks. So I don't want to gloss over those. But before I get to that, I want to talk about the opportunity and frame it in two ways. There's an opportunity to optimize our businesses by connecting these devices that historically have not been connected. And then there's an opportunity to transform our businesses. Now, through business optimization, it's really a focus on the bottom line. How do we do things more efficiently? How do we decrease downtime for our operational technology? How do we reduce maintenance costs? These are all things that with IoT, the benefits are almost immediately obvious, that by remotely monitoring our devices, we have a way to do a predictive failure analysis so that things don't break in the field, that we replace them before there's a problem. We also can optimize truck rolls against our predictive maintenance schedules so that we don't have to send a technician out, on a costly errand to go and check on a piece of operational technology that previously wasn't connected, but now is connected. We can send that technician out only when it's right and with the right equipment and optimize his or her route to that device. So these are all things that are business optimization. Now, the beauty of IoT is that, yes, it immediately delivers benefits that allow us to optimize our businesses and generate returns on the bottom line. But we're also finding that IoT is going to change the way that we live. It's going to improve healthcare. It's going to improve safety. It's going to improve standards of living. And also, there's going to be great social benefits that are generated by connecting these devices, capturing the data from these devices, and then generating insights from these devices. Our view of how this will happen will be in 3 phases. And these phases aren't necessarily sequential. These phases are going to affect industries at different rates and at different speeds. But fundamentally, I think all the industries, and it will be all the industries that are going to benefit from IoT, are going to sequence through the evolution of IoT adoption by first connecting, then generating smarts or intelligence with the devices that they have connected, and then ultimately deploying systems that allow for a greater autonomy and software-defined functionality with those devices. Now, it's a question of which industry you participate in as to when you will begin connecting and then evolving through these phases of IoT. But we do see that every industry for that matter that uses operational technology is going to benefit from IoT. But first, what we need to do is we need to connect the devices. And I would argue in the primary industries right now that are in the initial adoption phase of IoT, slightly beyond the early adopter phase, from my perspective, we're in the era of connecting things. And we're quickly migrating or evolving to the era of generating intelligence from those things that we have connected. Now, like I said, there are some risks, and I think I'd be remiss if I didn't mention that we have to be very concerned about security. Everybody's probably heard of the Mirai attack, where there was a DDoS attack. It was classified as an IoT attack because hackers went in and they found vulnerable endpoint devices that were connected to the internet where the username and password had not been changed from the factory default settings. And these risks are real. I mean, what you read about Mirai, what you read about other examples of security threats, I think people are familiar with the HVAC system on the top of the retail chain that was an entry point for hackers to get in and ultimately breach the network and capture credit card data. These things do represent a real present danger for our industry. But I don't think that it should scare us away. I think we should be vigilant, as we are being, and I think that we should be conscious of the new threat vector that's present with so many devices connected. But it also creates a whole new industry for security experts to help us create entrusted systems, help us create systems that will create a network of safe, secure, connected things. So The reason I pointed out in the beginning of the talk is to acknowledge it and to emphasize that it's very important that we do remain vigilant. And if we want to see our industry grow at the pace that we all know it's capable of growing, then we want to make sure that we address security and we don't overlook it. You know, as I said, and I had mentioned to this, the Mirai attack, there's also another attack that I like to talk about that I think fewer people are aware of. At the St. Regis Hotel in Shenzhen, about a year ago, there was an individual who was in his hotel room, and these are smart hotel rooms, and with an iPad that's available in the room, you're able to control the electronic devices within the room. You can turn up the heat, turn down the heat, you can raise and lower the blinds. There's nothing safety critical that you can do with this iPad, but there are some creature comfort things that you can affect by using this connected system. Now, this individual, he realized that if he was logged into the devices within his room, that he had enabled himself to be behind the firewall, and he could go and control devices in any room. Now, this was a vulnerability that was a system-level vulnerability that was part of the design of the system. This wasn't somebody who had used a sophisticated hacking tool to get behind a password through brute force attack or some other means. He simply exploited a flaw in the design of the system. So again, it's a reminder that we need to be thinking about how to design these systems in a way that we don't present vulnerabilities. Now, in this case, if somebody raises or lowers your blinds in your hotel room without you knowing, it might be an inconvenience. I'd argue it doesn't present a safety risk. Certainly doesn't endanger your health, but it does represent, you know, an example of a situation that we all, again, need to be vigilant and plan for. So having discussed the risks, I think there are tremendous rewards. And what I'd like to turn my attention to now is talking about what technology is facilitating us as an industry, those of us who are on this web conference today. What technology is enabling us to go out and create new systems and really deliver not just optimization but transformation for our industry? And essentially, you know, it's what IoT is all about. It's the bridge between the physical world and the virtual world. And the physical world, I would define as the operational technology world. The virtual world is the information technology world. And we talk all the time, I probably use this phrase every single day, that IT and OT are converging. And it's our opportunity, you know, be us either from the OT side or the IT side, to connect these devices together and leverage the benefits, historical great benefits that have been delivered through OT, and combine those with the great benefits that are available through IT. And it's as simple as ensuring that you have sensors on your OT that is connected into a cloud environment where you're able to now, in a virtual setting, view what's happening in the physical world. Wind River has been participating in this OT world, like I said, for almost 30 years. And our software at this point has been deployed, as you can see, in over 2 billion devices. Most of these are discrete devices. Most of these devices historically have not been installed into environments that are connected to the internet. In fact, our customers historically have not wanted their device traffic to touch the internet. So now, understanding the benefits that are available to our customers if they go ahead and unlock this data and they connect it into a virtual environment, they're asking us to come back and help them unlock this data, take the sensor data, take the machine data, and connect it into a virtual world, into a machine cloud for devices. Now, we take our responsibility very seriously because we've been helping our customers build mission-critical safety critical things, systems, aircrafts. And I like to say that when something is so important that it simply must work, it gives you an example of why Wind River exists. We are here, in a nutshell, to make sure that embedded systems, embedded devices, aircraft, that they work. They can't fail. So now we're applying this same capability to critical infrastructure in the Internet of Things. Let me dive a little bit deeper and just tell you a little bit more about Wind River and what we aspire to do. As the software arm of Intel's Internet of Things group, it's our aspiration to transform our customers' business to deliver the promise of a software-defined world. And we focus every day to make the reality of a software-defined world safe, secure, and reliable. With that, we define critical infrastructure on the graph that you can see, or the chart you can see rather, on your screen. We define it into 16 different sectors. All of these sectors, as you can see, represent industries and use cases where technology serves the community in a critical capacity and it cannot fail. Now, we participate as a company historically in all of these industries, all of these critical sectors. And we're finding now that without exception, all of these industries, all of these sectors are looking to IoT enable some level of their operational technology. So at a minimum, they can have connected devices that are delivering their data into a virtual world where they can generate insights from those devices. They're also looking to transform the way that they operate by not just generating insights from the data that they're capturing, but also from remotely managing those devices and then creating entirely new services from those devices. Now, with that, there are many things that we think about. It's trivial to just say that we're going to connect the things in an operational environment for a critical infrastructure sector. In doing so, there are a lot of considerations, and I have an abridged list here on this slide that shows you the things that we think about on a daily basis, least of which would be security and functional safety. But beyond that, we have to think about service continuity. We have to think about the life cycle of these devices. A lot of these devices, when they go in not just for 1 year or 2 years. They go in for 15 years. They go in for 20 years. And we have to consider that as we're building these systems. We also have to think about accessibility. These devices are not in easy to reach places. These devices are, as you can see in the backdrop here, over water in oil rigs. They're in wind farms. They're in environments that are not safe. They're environments that are hard to access. Extending that, there's also regulatory environments that we must consider. A lot of the critical infrastructure sectors are heavily regulated. There are legal requirements that are imposed on suppliers into these industries. And then a couple other things that I want to note, there are network issues that we have to think about. We don't always have the ability to enjoy a persistent network connection. There's latency issues that we may be subject to. And then last but not least, we have to think about interoperability. Different systems from different vendors installed in different generations, all of these issues contribute to things that we need to consider when we look at interoperability among the systems. As I mentioned, functional safety. This is something that we're translating from our years and years of experience in the aviation industry. And real-world systems, and I'm not just talking about jet aircraft here, but real-world systems have the potential to cause harm if they're not designed and managed properly. So it's our responsibility to translate what we've learned from the aerospace industry in a highly regulated environment and not only comply with regulations, but help pioneer regulations and functional safety certification levels that will allow our customers to operate these land-based systems as safely as we've been operating air-based systems. So how do we do it? In my business unit, we focus on something called the IoT device lifecycle management. And with this lifecycle, we first establish a connection from device to cloud. And that's in the deployment phase. Then once we have this connection, we are able to then monitor the device traffic coming off of the thing that we've connected. With that connection, we have awareness into the state of the device, and we can also communicate back to the device and provide updates to the device, as you see as you continue through the life cycle. But first, with the data that we're taking off the device, we generate insights, and that allows us to better service these devices. And these devices, I mean, there are thousands of things that you can consider, the devices would be. And all of these things, if they're electromechanical, they're going to need maintenance at some point. So taking data off these devices, using algorithms to understand failure rates and understanding conditions under which the device is known to fail and predictors of failure, we can then dramatically improve service. Again, this translates into a bottom line financial benefit, but it also translates into a health and safety benefit. If we can prevent things from failing because of the data that we're taking off the device, and we can predict and prevent failures, then it's not just a financial benefit that our customers are realizing. We're generating real social benefit in the form of improved health and safety. And as I've said, in this device lifecycle, getting device data is not the only thing that we do. We also have the ability to talk back to the devices and manage those. Beyond that, as I've said, updating the devices with that two-way connection. If we need to do a firmware software update to the device, we can easily now do that. And the last part that I want to talk about that I think sometimes is overlooked, but it's very important, certainly in the context of considering the safety risks that our industry can potentially face. We help to elegantly decommission devices. And if you don't do this in a well thought out manner, you create security vulnerabilities by having devices on networks that are still out there, maybe unattended. And this is something that we definitely do not want to permit as we go out and deliver safe and secure IoT. So these are the 6 phases that we focus on. These are the phases that we have in conversation with our customers every day. And I invite you to think about these as you're going out and considering either deploying an IoT solution or in building an IoT solution that you would deploy for your customers. Bigger picture, I talked about the 3 phases of IoT. There's connect the unconnected. There's generate insights from that data, which I defined as generating smarts or intelligence from these connected devices. And then ultimately, there's gaining autonomy across the systems through autonomous software-defined systems. And within our portfolio, we not only focus on connecting devices and rolling them into a device cloud, we also focus on how do we enable critical infrastructure to benefit from software-defined capabilities. And we have a platform that will allow our customers to virtualize their network and compute resources and then run software-defined services on top of that infrastructure. We're also extending this to the concept of fog computing, because running a software-defined application, you can't limit yourself to only running that software-defined application in a data center. I talked about in a previous slide that there are many considerations that we have. Network connectivity, latency. These things require us to think about distributed computing, or a new term that I like called fluid computing. And fluid, I think, combines, what you may have heard with discussion of fog computing during this conference or in other events that you've attended or analyst reports that you've read. But what we're doing is we're helping to define the virtualized critical infrastructure that allows you to then run these software-defined services in a fog node, at the edge, or within the network. And this is a little bit more expanding out how we accomplish this by extending the control loop beyond the physical device on the factory floor. And this is an environment where now we're talking about a control system in a factory. You would virtualize the compute resources where historically you probably would have run a DCS or PLC, closed loop, lockdown infrastructure. Now we can virtualize that compute resource. And like it says here, we allow you to extend the control loop beyond the physical device on the factory floor. This would allow you aggregation of multiple control loops and the data sets. And this provides, like I said, I'm reading here on the left-hand side, platform for additional operational technology processing. Analytics is the first thing that comes to mind, but there's other things that you would want to do. Create dashboards, real-time access to information, obviously real-time access to insights, using the metadata off your factory floor, combining that with the other metadata that you might be getting. A good example people like to think of is combining that with weather data. In a factory, maybe that's not as relevant, but if you're operating in an external environment where weather is a factor, you want to be able to take advantage of that metadata. And then it also provides an interface for exposing data to asynchronous learning loops. And this is where artificial intelligence comes into play. With machine learning, I think everybody who's on this conference, I would expect, is probably very familiar with the evolution of artificial intelligence and how quickly that whole sector is evolving. These systems now lend themselves perfectly to delivering data to the artificial intelligence systems that we're seeing emerge. There's another construct here that our CTO has been discussing recently. And as you see this build out, you can see on one axis, you have from discrete system up through the cloud. And on the other axis, you have custom compute migrating out to the other end on the right-hand side of the chart to general purpose compute. Historically, operational technology has lived in the bottom left-hand side of this chart, and then general purpose data center, enterprise class systems have lived out on the right side of the chart. Now, fog nodes, which is an emerging and new compute category, is where we take the operational technology, we connect it into the virtual world, but we can't tolerate connecting it only into a data center, which might be centralized in one or two locations around the globe. We need to have that compute either stay right there next to the device or not stray too far from where the device is. And by not straying too far, in the fog node, I mean you might have one compute array within the factory, or in a smart city, you might have fog nodes scattered around, every few kilometers in an urban environment where you wouldn't be dependent on persistent connectivity and latency issues to a data center that might be across the country or across the world, potentially. So I've talked about a lot of things, but let me see if I can combine these things and articulate them as a portfolio that we offer. As I mentioned, and you look up at the top here, we have our device cloud, which is our IoT device cloud, which allows you to enroll devices into a machine cloud. With that, we have a portfolio of products called Titanium. And Titanium is a virtualized compute node that allows you to run software-defined applications on top of the compute node. And we can run that compute node in the core network, we can run it at the edge, or we can run it on the control plane in a fog node. Beyond that, Wind River historically is known for our operating system products. The VxWorks product is our real-time operating system, and then Pulsar and Wind River Linux are our open source operating systems. With that, we also have IoT agents that will allow you to natively connect your devices built on our operating systems into the Helix device cloud. And then we have a system simulation tool called Symix that will allow you to run system simulation. And it's important to emphasize the word system because there are a lot of simulation tools out there that might give you a single view simulating a single function within your environment. And what Symix does is it gives you a system level view so you can do a simulation of the entire system. Being part of Intel, being part of the Internet of Things group, and hopefully you've had a chance to attend several or many of the other sessions during this Developer Fest, you'll understand that Intel has a wide breadth of solutions available for the Internet of Things market. Having said that, most of the things that you probably are familiar with in the Intel portfolio are hardware-based. And when Intel acquired Wind River a few years back, they did so with the express purpose of ensuring that we have software capabilities that directly complement our hardware capabilities as an organization. So the last few minutes I have here in my presentation, I want to talk about how we unlock business potential with IoT. And I'm going to do that by sharing a few examples with you of real customers that are using our technology today and reaping real benefits and seeing real value by connecting their devices. And what I'd like to do is start with a customer of ours in Europe called Parkion. Parkion is a smart parking solutions company, excuse me, focused on smart city deployments. Now, Parkion's base platform is a smart parking meter. I would imagine at this point we've all encountered a smart parking meter where we can designate our parking space, we can use a credit card to pay, we might be able to use our smartphone to conduct the transaction. Many of these smart parking meters give us the chance to renew our parking remotely. We don't have to walk back to the parking kiosk. And there's some immediate benefits that we as consumers are realizing from these smart parking meters. So Parkion has deployed thousands of these now, and they're upgrading them to now include approximately a 10-inch digital screen with enhanced connectivity capabilities, including enhanced capabilities to interact uniquely with the person that they're conducting the transaction with through their smartphone. These systems for Parkion start out as parking meters. The cities that deploy these benefit by greater efficiency in deploying paid parking across the city. They no longer have to invest as much in maintenance costs, in individuals' time, or in payroll, deploying folks out to collect payment from these machines or to service these machines, because these machines will advise a city manager if they are, excuse me, connected and in good working order. But beyond that, the Parkion Smart Solution meter is also a point of presence. It's almost a ubiquitous point of presence now in the smart city center. And beyond parking, it becomes a digital kiosk that will allow individuals who interact with it to consume more electronic goods. You know, maybe it's buying your metro ticket or buying your bus ticket. Maybe it's buying tickets to the theater. It's also an advertising hub for local merchants who want to interact with individuals who are walking next to these parking kiosks. Beyond that, as a point of presence in a smart city, it's also there for the benefit of public safety. It can help with interacting with the general population in the event of an emergency. And those are just, you know, some of the initial benefits that we're starting to understand are available to us through a connected parking system like that. The next example that I want to give is a particularly fun one. As the father of a young son, anytime I get to talk about a fire truck, it's always fun. I like to be able to translate what I do into helping firemen put out fires. I can take this home and brag about it a little bit. But let me tell you what Waterous is doing. Waterous is a US-based company. They build fire suppression pumps that are fitted onto fire trucks. And these fire suppression pumps, they are probably, you know, your classic physical, mechanical, operational technology equipment. Historically, they've had no electric component to them. However, now, waterists are fitting these pumps with electronic sensors, and with the help of Helix Device Cloud, they're able to connect these devices and the sensor data that they're capturing into the device cloud, and they can monitor the real-time performance and modify the real-time performance of these pumps, and then they can also troubleshoot issues and perform preventive maintenance, which ultimately has at least two benefits. One is that it improves the performance in real time of mission critical equipment that's being used to protect human life. Beyond that, it helps ensure that this equipment is well maintained in working order, and they minimize downtime. Beyond that, it translates into reduced cost to maintain the equipment, which translates into cost savings for firefighters, fire departments, who either benefit from cost savings, or it allows them to take that cost savings in what they were traditionally spending on firefighting equipment, maybe invest that in training, or maybe invest that in hiring more firefighters. The next example I'll give, the second to last one here, is from Bosch. And this is a combined project that we've worked on together with our parent company, Intel, and with Bosch. And Bosch have created the microclimate monitoring system. The microclimate monitoring system is a remotely deployed climate monitoring system that's about the size of a large lunchbox that fits atop a utility pole. And inside of that box, there are a few dozen environmental monitoring sensors that, once deployed, connect back into a remote data center using Wind River Helix Device Cloud, and allow city managers to do 24/7 real-time monitoring of the environment. Now, you probably know that environmental monitoring has been happening for years. Challenge is that it's very expensive to do and it's not pervasive. Reason being is that to deploy an environmental monitoring station, you needed about a couple hundred square foot lab in a city center. It would be one point of presence or maybe a couple points of presence, and it was very expensive. With this, we can exponentially increase the number of locations while we bring down the costs, by a factor of 10x to deploy these. And this has become a very practical, very low-cost solution for smart city managers who want to do real-time monitoring of their environment. In fact, we're starting to see cities across India who previously would not have been able to afford environmental monitoring now starting to adopt these solutions because the price point has come down so dramatically. And with this, they're also going to be able to extend the capability of the environmental monitoring solutions to start to do other things. Again, it's an analogy that we use with the Parkion solution. It's a point of presence in a smart city that starts out delivering great benefit and value to the citizens of that community. But because it's a point of presence, because it's a dynamic platform that represents operational technology that is connected into a cloud environment, really it's up to us. It's up to you on the call. It's up to the folks that you work with to start to leverage these platforms and let IoT really go out and help us all transform our businesses. So with that, that's the conclusion of my prepared remarks. And I'm excited with all of you to go out and unlock the true potential of our businesses with IoT. I'm going to go back now and I will make myself available for questions. End of life announcement for Intel IoT technology featuring Wind River Intelligent Device Platform XT version 3.1. What is the message here? You mentioned Wind River in your speech. Yeah, so let me speak specifically to the technology that you have referenced here, the Intelligent Device Platform. This was part of a program at Intel called Moon Island. And this was a precursor a couple of years ago to where we are now in helping the market adopt gateways. We wanted to seed the market. We wanted to create reference platforms that we'd make available to our ODMs and our OEMs. And we put out the Moon Island platform. In that technology stack was IDP. And we've now evolved to a strategy of promoting Linux as the base operating system with gateway profiles above the core Yocto Linux distribution. And Wind River has a distribution called Wind River Pulsar Linux that is the new platform. So if you were using IDP in the past, I direct you to Pulsar now, and then connecting your devices with the Wind River Helix device cloud. It's the combination of those things in a best of breed layered approach. Mr. Sabaranath, I thank you for your question. I hope I've pronounced your name correctly. Let me see here. I am from India. I am undergoing deep research to apply advanced technology with IoT for smart farming, digital marketing for arts and crafts, smart education, IoT secured entertainment for the film industry, smart retail and supply chain management, smart healthcare, connected health, and smart construction. I am seeking your advice regarding Intel products for IoT. Really, there are more barriers. I am failing again and again. I successfully done more prototyping projects, but while coming to real-time professional projects, I am not getting proper shape to design. My question is there any standard operating procedure for designing IoT to transform traditional into smart industry, smart in each and every sector? Well, I'll be candid with you. The state of IoT is that we are in early days right now, and the supply chain is a little bit complicated. That's probably putting it mildly. There are many vendors that have to come together to create and deliver a solution to their customers. So I think what we have to do is understand where we fit in the value chain, where we fit in delivering a solution to an end customer. There's no standard approach, I would say. There's a coordinated approach that have to happen across multiple different suppliers in the supply chain. Now, there is a great resource out there. If you've been on the Intel Internet of Things Group website and you visited the IoT Solutions Alliance site, you will see that there are hundreds of different partners that have all come together. They've been categorized, and we present different solution options as references that you can go and take a look at and hopefully find yourselves fitting in the context of one of those solutions. If you're not participating in the ISA, I would encourage you to join that organization. And if you've not had a chance to go through the resources on that page, I invite you again to dig in, look at the resources that are available to you, and then maybe use those as a guide. I'd also offer you this, that because we are in the early days, there's still a lot of opportunity to define yourself in the IoT value chain. And quite frankly, that gets me kind of excited to think that we can go and still define ourselves. There's a lot of competition, but there aren't really identified winners in each of the different segments of the supply chain. So I'd take advantage of that opportunity as it presents itself. There's a question about if we're participating in the Smart Cities initiative by the government of India. I can't give you a definitive yes. However, I do believe that Bosch with MCMS is participating in this initiative. I would have to research this, or invite you to just look at the Smart Cities initiative being run by the government of India and reference if Bosch with their microclimate monitoring solution is a part of that. We, Wind River, typically go through our partnerships to reach the end user. So a smart city, for example, a city of Pune in India, is benefiting from using Wind River Helix device cloud technology. But we, Wind River, and in fact Intel, are not directly engaged with the city of Pune. We're working through our partner, Bosch, and Bosch in turn is working with L&T as a system integrator locally to deploy that. So those are two vendors that you may want to take a look at and see if they are participating in this initiative. No accelerated use and further development of IoT reference architectures, like, for example, the architecture reference model of the project IoT, how to design. Well, I'm in the software part of Intel, but it's quite a acronym for those of us who have an affinity for Intel x86 architecture, that they would call that ARM. I am, regrettably, I'm not familiar with this model. There are a number of consortium out there that I would say, I'm a fan of industrial internet consortia. But this one, regrettably, I'll take a look at it. I'm not familiar with this one. Here we go. Market-ready solutions. Yes, that actually is a great point. The MCMS deployment with Bosch is part of a program that the Internet of Things group runs called Market-Ready Solutions. And currently, there are a few dozen market-ready solutions available. These go and look at different requirements for different market segments. So these market-ready solutions take a vertical approach to putting together all of the components that are necessary for a solution, so that an end user, like a smart city manager, can pull off the reference example for a market-ready solution and can deploy an actual solution that we, Wind River, or our parent company, Intel, might be a component of. And these market-ready solutions, that list is growing. Like I said, there's a few dozen of these now. These are available and published on our website. And thank you, Sabitha, for pointing that out. So I would point everybody on the webcast to MRSs as a good example of use cases that you can look at and deploy today. Or if you're a developer and you'd like to participate with us in creating a market-ready solution, there's a wonderful opportunity for that. So I'd invite you to also consider that option, depending on what you're focused on with your business. And yes, I agree, Wind River can help. So can Wind and Intel be a solution for, quote unquote, difficulties in developing a business which embraces the full potential of the Internet of Things? Candidly, I would say yes. The way that we like to approach is we start with a vertical industry, and then we go and we look within that vertical industry. What are some of the tough and challenging problems that they're trying to solve where IoT can help? As an example of that, I gave three case studies today where in fire suppression, in smart city parking, and in smart city environmental monitoring. Beyond that, we've got customers in a wide range of industries who are all trying to solve unique and challenging problems where IoT can really help them. And going back to the premise of my talk, which is IoT is evolving along three vectors: connect, unconnected, create intelligence through these connections, and then ultimately create a software-defined autonomous world. That's the way we logically approach it, by first connecting things, then applying that intelligence, and ultimately in a controlled way, letting these systems interoperate autonomously. I would refer you to the other sessions that have been hosted by my colleagues at Wind River and also my colleagues at Intel. They put together a fabulous conference with I think about 50 different sessions. Personally, I've been very intrigued by a number of these, and hope over the next few days with the video archives that I can go and take a look at some more of them. I want to express my sincere thanks for your time today, sharing some of your time with me. And with that, we're going to wrap up. Thanks so much, and have a great day.